Hello, everyone. Welcome to this session. And this is really quite a day, isn't it? Because we've got the England versus Denmark match. We've got a sunny afternoon, at least here in North London, hopefully where you are too. So we're expecting a small and select audience, and you are one of the lucky ones. So welcome, welcome, welcome to this webinar, which is New Technologies for Data Protection, with our good friend and regular speaker, Ulf Mattsson, who's speaking to us from Connecticut in the US. Now, this is, of course, a meeting of the BCS North London branch with Central London branch. My name is Darlin Basu. I'm chair of those two branches, and I've got a great bunch of colleagues to celebrate being in the BCS and being part of this fine body, and also putting on this webinar tonight for you. Now, you can see details of the webinar right there, and we're going to launch into it in just a minute. So please just quickly read the webinar details if you don't know them already, especially read about Ulf, the Chief Security Strategist at Protegrity, who, as I say, is broadcasting to us from his home in Connecticut in the USA. He has indeed got a distinguished career and is also a very prolific person in terms of US patents for particularly IT-related products and services, and expertise in lots of features such as data, privacy, cloud, and security. Well, we're not going to keep him secure unto ourselves any longer, because I want you to join me in welcoming Ulf Mattsson.
Thank you. Good to see you all. And I'm waiting for the day when I actually can travel to London again. I love London. So let me share my screen here. In a second, it will come up, and I hope you can see it. So let's start with the second screen here. A brief introduction what I am doing.
You want to make it full screen?
Yeah, let's go into full screen. Let me get that going. The control is behind the pop-up here.
Press
so
F5 on the keyboard.
F5, Control F. Okay. Oh, yeah.
There you go.
Sometimes I need a little bit of technical assistance. You know, I used to be the Chief Technology Officer, not anymore. I'm the Chief Security Strategist now, so that tells something. And I used to be in a couple of different companies, many years at IBM. Yeah, I founded Protegrity, and I worked in a couple of cloud security companies. I've been very active in forming the PCI DSS standard. And as you know, it's a lot about encryption tokenization and cloud. I am active with the Cloud Security Alliance. We are currently working on quantum computing, and I continue to be active in the financial services industry, forming standards for ANSI X9 in America in the areas of crypto, tokenization, cloud, and quantum. On the right-hand side, you can see a couple of my recent articles in the ISACA journal about a lot about data privacy, data security, and more about analytics and machine learning. At the bottom right, you can see some more articles in the ISSA journal. So I'd like to, we have a lot of good time together today. So I like to cover quite a few different new technology areas, or fairly new, like machine learning, multi-party computation, homomorphic, differential privacy, and k-anonymity, and other ways to protect your data, like synthetic data, pseudonymization, anonymization of data. It's particularly important for GDPR and other regulations. I'm then going into zero trust architecture and position that and talk a little bit about the difference between that and zero knowledge proofs, which is becoming more and more important also. I will then move down to different trusted environments. So we used to have the HSM for key management, the hardware security module, and now in the cloud environment in particular, there are newer options like trusted execution environments, where you can protect your secrets from other people that are roaming around in the cloud environment. And finally, I will talk a little bit about how do we need to prepare for the quantum crypto, quantum computing. And throughout the presentation, I will touch on some regulations and standards. This is what we're used to, the old corporate environment, the green box, the dotted green box, and we started to use more and more cloud services. And we have this magic and sometimes confusing relationship here between the green and the yellow. We refer to it as shared responsibility, and it needs to be reflected in your contract with the cloud provider, of course. And at the bottom, I have these databases or data stores. So we now have corporate data on-prem, and we are increasingly storing data and also sensitive data in cloud environments. More and more organizations are going in that direction. They are storing more and more sensitive data in cloud. So it's changing. Now everyone is working from everywhere. So we're adding the red box here, where people are storing data, sensitive data, sometimes corporate data, sometimes in a cloud provider that we may not know about, and that we definitely not can control. There's typically no relationship or contract from a corporate point. And users are also working on their laptops and mobile phones, and sometimes they are downloading sensitive data, corporate data. So we have a situation that is getting maybe out of hand, but definitely we need to address that, because of course risk is going up, because you have more and more data in these environments that we do not have corporate control over, and where maybe our old best practices are not applied, and we are losing control. So we are no longer controlling our environment. More and more data is stored in environments that we do not control. So we need to do something. The situation is getting worse over time, and we cannot stop this trend. But I put data in each box here. So what we at least can do is to apply basic cyber hygiene to our data, meaning make sure it's backed up, make sure the data is protected. At least you can protect the data that you're storing in these environments. Even if you don't control operations in the environment, you don't know if they are attacked and from what side the attackers are coming. And it's changing. You have the ransomware creeping up more and more. You have infrastructure issues. You have ransomware getting in and viruses getting in through our infrastructure and our application stack. You have things like SolarWinds and more is coming. You have the more recent scare from Microsoft that is kind of following the same pattern. So we have to assume that the attacker is already inside. And we also should be prepared to attacks from different sides. We cannot know where the next attack is coming from. So we need to add to our strategy, and they are in most cases going after our data. The end game is usually to get to the data, our data. What is regulated? Yeah, we have more and more regulations coming up, and many of them are data privacy focused. So a good starting point is to be better at finding our data. So actually know our data assets. Where is that data? How is the data flowing? And from a GDPR point of view, it's required. You need to know where the data came from, who you are sharing the data with. And it's just getting more and more focused. Fines are creeping up. Court cases based on, for example, GDPR is creeping up. We have court decisions recently in France and other countries, Portugal, and so that are starting to show a pattern. What do we need for cross-border transfer, for example? What kind of extra do we need to add? So we talked a little bit about that. It's starting to get more clarity every month. And we know that the Schrems 2, it was a big question mark, and we are going to get more answers over time. So Gartner is saying that for the next 3 to 5 years, the factors that will impact our security function are at the top, the increasing regulations and also the evolving threat landscape. So let's get back to our data. A lot of organizations are concerned about the increase in ransomware, and it's starting to hit smaller organizations also. And we know the trend is not just to encrypt your data, but to exfiltrate data and if you don't pay, we will disclose your data. And so let's talk about how can we make it harder for them to succeed with those attacks, and also create a formula, a pattern that can limit the damage from other attacks that will pop up. So of course, on the left-hand side, we need to monitor the access, unusual access to our most sensitive data. We may not be able to monitor all access to all data. There's a lot of noise in that information, but at least we can track unusual behavior towards our most sensitive data. And we talked about protecting the data. So if we protect the data, when we get it in the ETL loading process. And for example, the trend is that organizations are not just using the ETL loading process, but they are throwing a lot of data initially into a data lake. And then they figure out where the data should go, how it should be put into different databases and so. And in that flow, we can start to protect the data, to pseudonymize data, anonymize data, encrypt some data, and put, for example, dynamic data masking in place. So you have this fine-grained filter in connection to your access control that will determine how much data do I want this group of users to see. Offline backups are, of course, critical when we talk about the ransomware in particular. So the backups, they must be disconnected. If they are online, your ransomware probably already hit your backup. And we need to test the backups so we quickly can restore and get the business up running. Because we may never get the encryption keys and get our ransomware data back, even if we can pay the ransom. And it would be good to get out of that business of paying criminals. So testing our restore procedures is becoming more and more important these days. Talking about data protection. So what should I use? Data protection is a continuum that you can make it easy or hard. So on the left-hand side, I put the easier things that will have minimal impact on you, on your business, like access control, transparent database protection or encryption, where you basically encrypt the lower layers, the database table spaces or file systems, database file systems. And you can be compliant by taking those measures. Encrypted, yes. We have access control, yes. And then it comes to monitoring, and that's the tricky part. But we talked about monitoring our sensitive data, and that can take us far. Yeah, really being focused on the data that we found to be sensitive. In our discovery, we pinpoint the data that we want to focus on. On the right-hand side, we talked about masking, dynamic data masking. So you filter, you apply a filter on the way out to the user. And it can be very transparent. It will not impact your infrastructure at the lower levels. And you can fairly quickly implement that. On the right-hand side, we're talking about changing data, how it's stored on a granular basis. And we know that the PCI payment card industry, they started to use tokenization because it was very effective compared to encryption. It gave you a highly transparent way of granular protection for payment card data. And that approach can be used for a lot of PII. Numbers are just numbers, so you can replace them with tokens instead. And tokens, the good with tokens is that they are highly usable. You can control the format much more than encryption can. And it's also a very fast from a performance point of view. So the scalability and performance will not be much affected. And the name of the game is to actually use the tokens in most business processes. So it becomes like casino money. That's what you trade with. And in many applications, you don't need to see the real data, the full real data. You don't need to see the full credit card numbers or full social security numbers, because a lot of use cases are only interested in part of that information. So we can keep the disclosure of information down. So summarizing what I talk about is the effort level is kind of measuring the total cost of ownership. You have to buy a product, you have to configure the product, you need to do sometimes migration of applications and databases, and you need to manage. You need to manage your policies. So the total cost of ownership can be it can be easy or it can be hard. So I tried to summarize what we talked about on the previous slide, that there is a scale where you can start easy, and then in subsequent steps, you add more and more, you add stronger protection, and you can quickly get a baseline of control in place. So what type of control are we talking about? Of course, you need to have access control. And we talked about specifying who should see what data. These different users or groups of users, they need different data. And the example here, we have name, address, date of birth, social, credit card number, email address, and phone numbers. You can filter out what data should go to the different groups. At the bottom, you can see the data flowing out from the database or the data store. And the black color indicates that that data might be encrypted all the way. It's just protected. That feed is protected, and in most cases, you are not using it. And the white color indicates that this is information that is in full clear text to the different users here. And then you have the gray areas. When that data is coming out from your database, it's masked or it's tokenized. So it's a medium level protection, or you are only disclosing part of the data, or you even are disclosing a substitute of the data, like a token. On the left-hand side at the bottom, you can see the technology stack, where these different transformations typically are happening. So the user client is, in many cases, user browser. There might be a gateway, a proxy, reverse proxy on the network before you hit your databases or before you hit your cloud application. And that gateway can do some enforcement. You do access control, do data transformations, you flip what the data looks like. And then further down in the stack, you may have a web application firewall to prevent some cross-site scripting and SQL injection. And it's kind of a basic function still, but they are not very good at it's basic. It's a network approach. So the network transaction cannot look deeply into the data. So that concept is really there. Then you have the web server, you have the application layer, database file and file system, and down to the device. So with this grid or this table, you can apply protection, different level of protection for your most sensitive fields. And it's all about being selective. If you protect everything, then it's kind of binary, on or off, and you're not really protecting anything because it's fully open to most of your users or attackers. There are so many different protection options to choose from. So how can we position the different data protection techniques? On the left-hand side at the top, we start with the clear text. So now we're talking about different data fields, data columns. On the left-hand side, you can see two-way protection, meaning that they are reversible. You can get the data back again. And many applications need to get the data back. Even if, so those are mainly operational, transaction systems. Sometimes in analytics and machine learning, you also need to get the data back. You need to know who had this disease, or you need to know the details of where is this event occurring. So in many cases, you need the data back. On the right-hand side, it's like you protect the data and forget. So you can anonymize, typically attributes, all kind of different attributes, columns and fields. Those techniques are one way. You cannot get the data back. It can be hashing, but we know that hashing can be ugly and not really transparent for applications and databases. It's a long binary. You can apply static data masking in case for you use it test systems, development systems, and so in the old days. Format preserving, there are more format preserving techniques that are highly transparent to applications and databases. And very popular these days is differential privacy. And it's a little bit similar to k-anonymity. It's basically about adding noise to your data for the purpose of lowering the risk level. For example, the risk of identifying individuals, which is critical to GDPR. And this can be applied in many cases in analytics and machine learning. It's fast. On the right-hand side, we're starting to see more and more organizations are using fake data or synthetic data, and it's a static derivation. We'll talk more about that, but it's basically generating fake data that GDPR is not concerned about. And it will not identify individuals, obviously. And it can be a way of providing, of course, test data, test dev system data that is more useful than just static data masking. It can be useful for data in analytics systems, machine learning, particularly training your machine learning model. And then you may apply it and do your inference on more realistic data or business data that is reflecting your business more closely. So these data protection techniques, they can be used in different use cases. Some are very slow, for example, homomorphic encryption. When is that good? For a few use cases when you need to share data between parties. It's very slow, but you are typically using the encrypted data here to do operations. So you use the encrypted data to do additions between fields, multiplications of fields. Those are the most common somewhat homomorphic operations that you can use. And another algorithmic encryption is the format preserving encryption. It's slow, faster than homomorphic, but most format preserving encryption are using 10 times of AES rounds. So FF1 algorithm is using 10 rounds, FF3 in the NIST standard is using 8 rounds of AES. So they are in the range of 8 times to 10 times slower than AES. That can be important for some use cases, but typically it's a pretty convenient way of making, I would say, soft encryption that is highly transparent. On the left-hand side, you can see the new generation of the protection, different forms of tokenization. Tokens are random, or they should be random. You need to validate the tokenization implementation because they look very different. There's no standard. They are random, and that's good because random cannot be broken. So you can measure the level of randomness by applying test cases. For example, the US NIST, National Institute of Standards and Technology, they have test suites. They have 15 different test suites that you can apply to your data to measure the level of randomness. Random is good because there will not be a quantum computer that can break random. Random is random. You can, of course, attack your basic system, your servers, your tokenization servers, but that's another story. That is about protecting key management and infrastructure protection. Tokenization can be very fast. Modern memory-based tokenization can be much faster than AES. So that's important for some use cases. Large databases in cloud, they can benefit highly from this modern type of tokenization. And on the left-hand side, if you're using clear text data, it's fast, but you have the liability to deal with. This is a summary about performance and speed, a summary of what I talked about before. On the left-hand side, if you had the old tokenization approach with a vault, a database vault, basically, you may only do 1,000 transactions per second. It's good for some payment systems. It's centralized, so you have it's like a booking system, reservation system, where you need to go to the ground truth every time. So it's not really distributed and good for those use cases. We talked about format preserving encryption. So you are moving up from, let's say, 1,000 transactions per second up to millions of transactions per second. Now we're talking about fairly powerful computers. It could be a Teradata system. It could be a cloud service. And they can speed up significantly. So we're starting to talk about millions of transactions per second. If we move further to the right, we compare it to AES. So AES, you can speed up AES by using the Intel chip with the NI verb or NI call. It can speed up 5-10 times if you have that. But we are moving faster and faster into what we are seeing on Amazon AWS, for example. The Lambda functions, they can run vaultless data tokenization at a speed of, for example, 180 million transactions per second. And that is not just the Amazon, it goes for other cloud providers, Microsoft Azure, Google Cloud, and so. And it's a little bit higher than you see on a Teradata. Teradata is moving more and more into cloud, so they are catching up from a cloud perspective. If you go down to a small system like an Intel E5, you can expect on that small system 200,000 transactions per second. So from a speed perspective, you have this variety, this spectrum that we need to understand before deciding what should we use for a certain use case. Use case is important. So let's talk about some use cases here. On the left-hand side, you have a payment application where you typically do your tokenization, you have the key management centralized, and so at the top you have a gateway that is encrypting information going into Salesforce. So you encrypt or tokenize sensitive client information before the data is exposed in Salesforce. I have the PI. I'm using the PI term more and more because particularly in the California CCPA and also GDPR, we are not just talking about individuals. It's starting to become much broader. So they talk about PI as information that can identify a household, not just an individual. So it's getting, the trend is that it's getting broader and broader. Vaultless tokenization that I mentioned is great for a data warehouse where you need to perform. So you have Snowflake, you have other newer databases that are faster and faster in cloud. So you have Redshift, you have many new offerings that are starting to be very attractive for analytics in particular, and also for medium-sized organizations. As data grows and you want, sometimes they can perform 100 times or 1,000 times faster than, for example, Snowflake. So you have Yellowbrick that is really fast, and other in that category. If we move down in the center here, we have an example of differential privacy or k-anonymity used for an analytics application. On the right-hand side, we talked about the masking for dev test or maybe synthetic data. At the bottom, I have another use case for homomorphic, where Microsoft have, as an example, the voting application, where voting records are keeping the confidentiality and integrity of data for election and voting applications. Where are the connection points here? So they are, many of them are related. So different use cases that involve machine learning analytics, they connect down to other technologies, some are emerging technologies. So for example, when you talk about homomorphic encryption, you may want to use an algorithm that is lattice-based if you want quantum safe algorithms, or quantum resistant, we should say quantum resistant algorithms. And in general, you need to start to plan for quantum computing for your PKI, your public key encryption, your certificate, your TLS, blockchain that is heavily public key encryption based, not just the hashing that is for Bitcoin, a pretty long hash, like a 512K hash, that's pretty safe, but Bitcoin and in general, blockchain is like Ethereum. They are based on public key infrastructure. So it's not just the hash that you see in the blockchain securing the chain. It's the whole infrastructure that can be challenged by this type of new encryption. And it's not just the quantum computing that we see at the horizon. It's also faster silicon technology that is getting faster and faster. And these faster technologies, they can attack historical data. So if we have historical data stored, those computers can look into that data and expose that. On the right-hand side, we talked about, or in the middle, we talked about how the right-hand side, like machine learning, can utilize trusted execution environments. It's typically an Intel chip in the cloud that is providing. It's not an HSM, hardware security module, that is certified, but it's a separate chip where you can hide your data, you can hide your code, your machine learning algorithms, and keep them private. So they are encrypted, your machine learning model and the data when it comes in, and then you decrypt that model into full clear text, and it's protected in the trusted execution environment. You can have those on smaller devices, but there's an interesting application across all the major cloud providers. You have it from Google, from IBM, and Microsoft. And for example, at Amazon, it's called Enclave, Secure Enclave. They recently had a preview on that, so customers are starting to move into that, but still evolving. It's still evolving. You have many question marks that need to be evaluated for different use cases. So going back to machine learning, the connection to quantum computing is that certain algorithms, machine learning algorithms, can be optimized for running on quantum computing. Not all machine learning algorithms, but some can really benefit from having the type of operation you get from quantum. It's not just faster, but they can optimize. If you go from machine learning and up, we already talked about that. You have different ways of anonymizing the data with the different models we talked about before. So this is kind of a map, a chart, how these relate. So let's go back to our new distributed environment. We said data is everywhere, and when you protect the data, when you encrypt the data, a key question, no pun intended, is where do I keep my secrets? Where's the encryption key? is the encryption key by the cloud provider. It sounds very close, too close to the data. In case I have a breach at the cloud provider, or in case government is coming in, it's wide open. Here's the key, here's the data, you can decrypt the data. So you may want to keep the key and have full control over the key. And it is critical for cross-border transfer. We will talk about that in a minute. We are used to control the keys on the left-hand side on-prem, and we should keep doing that. Or at least control it in an environment where we have, as a user, full control. It should not be able to, it should not be disclosed to the hosting provider, or at least managed and stored by the cloud provider. And they need the key sometimes to do operations, but for the most of the time, we should keep that key to ourselves. And moving to the right-hand side, we have no control. We don't know anything about their key management or where they store the data in many cases. And then we have the mobile environment or your local environment. Now people have home offices, and is that data protected? So we need to start to care about platforms that we are not managing. I mean, if we have a corporate laptop, we have some level of control over that data, and we can restrict it. If we have a corporate mobile, we have some level of control. But in many cases, we see that corporate data and other sensitive data are leaking out to laptops and mobile devices that is not issued by corporate. We have no control over that. So we need to think about this situation. Let's go back to a use case, a real-world use case. This is from a big bank in the US, and this is what we are working on with that bank. On the left-hand side, you can see different areas where we are talking about analytics, we're talking about cloud, we're talking about other technologies further down. We're talking about the timing, so we're saying some of it is long-term, the red ones. This particular customer said synthetic data is more of a long-term. They might rethink that and say, synthetic data can actually help us to get away from compliance issues and attacks, concerned about attacks and so on. But for now, they're saying synthetic data is something new. We don't understand it. So I think it will be, we need to educate organizations about what is synthetic data and how do you measure the risk level, and how can we will get back to that question. And then you have different quantum, the red and the yellow further down, where we need to start medium term to be ready for quantum safe algorithms. And also long term, when we are getting more and more advanced in machine learning, we need to think that initially machine learning in this bank is more like, okay, let's get machine learning going in a secure way in the cloud. And then think about where do we go from there? Where do we go into federated learning, you know, when you run distributed machine learning? Because you may not get the data. It's sensitive data. So you may not get the data, but the machine learning model can actually run locally. So you don't see the data because it's kept private. in that environment, but you can get the results back and then have the machine learning be distributed. So that's kind of a more advanced step that we're seeing that we need to dive into over time. I do not want to go into other details here. If you have questions, we can jump into all these other questions that are discussed in this bank. Secure AI and machine learning. This use case, again, this is a bank having credit card transactions, and they want to, it's an AML, KYC, they want to address fraud and risk, and they want to know the customer. Who am I paying? Who am I doing business with? So they want to analyze. In many cases, they want to, or more and more, they want to share this fraud data with other banks, with competitors, to get early warning, and so we have different use cases, and we started to gather information from all kind of different databases and file systems, credit card statements, customer information, and more at the top. We protect that before it goes into our analytics pipeline. The data lands in Amazon S3 buckets, and it's protected when it lands in there, because we do not want to have a Capital One situation where Amazon S3 bucket contains unprotected data that is disclosed. And then from Amazon S3, it goes into the Redshift and Databricks, where you have the machine learning data set. In this case, we're using, we moved from Hadoop into Spark jobs where we are massaging the data before it goes further into the real machine learning model. Finally, we are using Amazon SageMaker to make it easy to manage our machine learning. So the use cases that we identify beyond this initial project was different dashboarding, reporting, predictions, forecasting, simulations, and optimization. We concluded that we can apply the same approach for those type of projects. And the bottom line is that we can not just lower the risk. We can actually measure how much we lower the risk. We can also measure how the quality, how accurate is the output from our analytics and machine learning. And we can fine tune our model based on that. We can fine tune our data protection based on that measurement. And we need to have metrics to know if we are improving. And the bottom line is that we identified savings, cost savings by applying this. And it's very important to show some results. And then you can get then you can get the okay to apply it further. And it also helps to identify new opportunities, identify additional revenues. Talk about cloud. So we saw one use case was to put a gateway in front of cloud. So here we have a Salesforce application where you can put a gateway or a type of CASB, Cloud Access Security Broker, in front of your cloud application. So you have full control of encryption keys and the access control, and data is transformed. So it's protected before it goes into cloud, and the user on the left-hand side gets to see the right data. At the bottom, you can apply it on-prem for applications, other applications, and databases. And you have the key management control and policy control in your hand, centrally and across the hybrid environments. What about SASE? SASE is it's kind of a concept, framework, a concept that is bringing different technologies that control the access to cloud. So it's like bringing web application firewalls, network firewalls, CASBs, and other cloud control components together into a common framework. So you can see what's behind the SASE. You have the SaaS applications, the infrastructure and platform as a service. You have different type of management in the cloud. So that's how we typically position SASE in this. And here you have the architecture where you have the CASB in the middle. You have SASE to the right at the top. So you can see the stack here. Big data in cloud. This is a Google Cloud use case where you do the processing in Google Cloud. And you have the key management separated. At the top, you can see the management of keys and policies for access control, similar. The data is flowing in from the left. It goes into Google Cloud. It gets protected before the data goes into big data analytics, in this case using BigQuery. This is something that is used to control data in different geographies. At the top, you have a US-based headquarters that is controlling key management and policies and so. And a lot of the operation is done in Europe and in Asia. So at the bottom, you can see, for example, Europe, they have their own key management, HSM, backed with hardware security module, very secure. So this is a bank. And it's the model we talked about before, full separation of duties, the local protection of data, local control of encryption keys is enforced here. And it's separated from what they do in Asia on the right-hand side at the bottom. So it's implementing the same concept that we talked about before. Another use case with Amazon AWS S3 buckets. Here you can see the policy is and key management is kept at the bottom. The data is protected before the sensitive data flows up to the cloud, up to AWS S3 buckets. And this is kind of summarizing on the right-hand side what we talked about, having control of encryption keys and policies. Your central control, and at the bottom you can see the different cloud providers. At the top you can see your examples of different on-prem systems. At the left, this is what has been reported in different studies about why do we want to do this. So the first one is consistency. So customers are saying we're using best of breed cloud apps, SaaS applications, and so on. That keeps shifting. And next year there will be a new one, and we are moving depending on the financial needs or organizational needs. And in many cases, they are using an encryption key management system for on-prem that they want to use also across the hybrid environment with different cloud providers, multi-cloud. And it's also a trust issue. How much should I trust the cloud provider with my encryption keys and my clear text data? It comes down to criminals, attack scenarios, administrators, government surveillance, and so. And finally, vendor lock-in. If I want to move to a new service, I want to have certain control over my data, my encryption keys, and the policies. Let's go back to GDPR. We talked about moving data between countries, so cross-border issues. So the trends to put the stop to transfer. So I've seen many companies that were ruled to stop their data transfer because they do not have enough control or safeguards. What are these safeguards? So in March this year, a French court decided that if you store your encryption keys in France, where you have your operation, and you store the encrypted data in Luxembourg, where Amazon AWS is hosting your encrypted data, you're good to go. So this shows that these technical safeguards meet the standard, the new standard that is evolving, GDPR and cross-border. And they also have the legal safeguard to challenge access requests from any public authority to access data. And at the bottom, a remark is that they did not share health data, and the data is deleted after 3 months. So this is a use case that is setting one standard. A little bit about post-quantum. This is a roadmap that is taken from one customer project where they talk about what to do short-term, medium-term, and long-term. We touched on some of these before, but I want to point out that they decided to move to AES-256 for symmetric encryption and SHA-512 for hashing, and also signatures. In short term, they also decided to have a plan to replace the RSA algorithm for TLS and older SSL, and also replace elliptic curve crypto, ECC, because it's almost the same level of weakness for post-quantum algorithms. Medium term, they decided that they want to look at new algorithms like lattice-based and more down. We can see that they are monitoring the standards. I would say the American NIST standards in this area are world leading. They are guiding most of the world in quantum safe algorithms. So they are, even if the standards are a couple of years out, we can see the trend where they are zeroing in and moving to. So a little bit more about the landscape. This is some more data points in what we talked about before. You have the quantum at the bottom, you have machine learning on the right, you have the homomorphic and public key on the left. I put blockchain in here, I put TLS, we talked about these. So this is kind of summarizing with some verbiage about how they are connected. We know that privacy started after World War II in Germany. A big driver for that. People that experienced what happened in Germany, they raised early concerns about privacy. And it's spreading to legislation in other countries, not just Germany. We see Sweden, and we're seeing it all over the world. And I exemplified with the CCPA in California earlier. We have states in US like New York and Virginia and other states that are following. So CCPA is starting to spread over US, and GDPR is starting to spread across the world. Legislation that popped up are in healthcare, financial education, and more basic privacy and information security, and they are constantly increasing, as you know. We already talked about data flow mapping, but I want to emphasize that if you want to protect data, you need to know where your data assets are. And GDPR is also saying that you need to know where the data came from, how it's shared. So having this example of a discovery tool that is great, where you can get a lot of machine learning help from analyzing and finding and illustrating where your data is. IBM came out with a GDPR security framework where they are talking about this aspect as a starting point. Find your assets and then have the ambition to implement security by design. What is security by design or privacy by design? You should, over time, modify your applications so they are protecting your data and at that level enforce your security and privacy policies. So over time, you change those when you modernize. And so in the meantime, you can put the gateway in place to immediately enforce your new requirements or new rules for data protection. And IBM is saying that typically you can use encryption, tokenization, masking to enforce those controls that you are putting in place. Another case study, this is an international European bank that is hosting data in Italy, and they want to consolidate, they want to do cross-border transfer of data. They have data in Austria, Germany, and other countries. So they decided, this was highly sensitive data. It was both PII data and financial data. So they decided to tokenize the data, and it gave them a good cost benefit. Analytics, let's talk a little bit more about how we are bringing data together. We said in the middle here, we have data lakes, we have the ETL. We talked about organizations increasingly are just throwing the data into a data lake or using a traditional ETL process. They get the data into either cloud-based or on-prem analytics environments. They are using the data already protected. And one illustration is what we talked about in the use case before, where the data ended up in Databricks and Amazon SageMaker. What is Gartner saying in this? Gartner talk about emerging technologies. So in particular for AI and machine learning, they point out a handful or more technologies. And when it comes down to data privacy, they are talking about algorithmic trust. that model can help ensure data privacy. So they have 6 pillars in that trust model. Number 1, we already talked about SASE. Then number 2 and 3, they talk about explainable AI, which is answering the question, why did my model come up with this conclusion? And then you have number 3, responsible AI, and it's about understanding if my data is biased. Is this data, first, is it protected? And secondly, did I gather information across all the regions, across all type of populations that will give me the correct model? And further down, we have differential privacy and more that we talked about. So responsible AI and confidential AI are a little bit different. At the bottom left, we have the things we talked about: differential privacy, k-anonymity, and more details. We talked about synthetic data already. On the right-hand side, you have what we touched on earlier. You have the federated learning, where we said instead of shipping all the data into a central point or to your model where you're running the model, you may not want to do that. You may not do it for different reasons. So the trend is federated learning, where you ship out your different parts of the machine learning model. Ship those models out to different environments, bring data back. Yet another use case. This is interesting. This healthcare drug manufacturer, they use machine learning to, instead of doing testing on humans and animals, they more and more rely on machine learning. So this is just an example from that industry. Products and services, what do they use for implementing these things? We can see Dataiku, SAS, TIBCO, and others, IBM, and so are pretty high up here. Just an overview of the landscape. What do they typically do? It comes down to training. We talk about you can use different types of data to train. So on the left-hand side, you have those. You test your data, you evaluate your model, you do your inference, data inference on the model. And on the right-hand side, the output could be like a linear fitting, and at the top you have an example of a stack. What type of hardware, graphical processors and traditional CPUs, and they are running a stack of libraries. TensorFlow, for example, which is very popular. The vendor landscape is changing. So you can see that SAS on the right-hand side, they are moving up. This is machine learning platforms. And other companies are moving down. IBM is moving up, Google is moving down, and there are players that are shifting in importance and popularity in doing the machine learning that we talked about, importing data, running your models, training and inference, and collaboration. Typically, they ask, when you start a project, they ask, okay, so can I use Python, C++, Julia, or R? That is usually a starting point because you have a staff that know these languages. So put them at the top. And then you need to pick your frameworks and libraries. We talked about TensorFlow and PyTorch. used by or created by Google and Facebook, very popular. And then you go down the stack in the middle. All these are, the green ones are open source. So you get more and more specialized when you go down the stack all the way down to MATLAB. On the right-hand side, you can see just a couple of examples where they support mobile or cloud, support different operating systems, like Linux, Mac, and Windows. These are just examples of. We touched a little bit on secure multi-party computation. And I see more and more projects are talking about securely sharing data with others. We touched a little bit on different technologies. We talked about the left-hand side, where you gather data, you protect it, it goes into cloud or on-prem in the middle, in your analytics and data science, your machine learning environments, and you have the data from different parties, your partners on the right-hand side, where we started to talk about exchanging data, homomorphic encryption, and other ways to securely communicate or sharing data in a secure way, you know, so they can operate securely on the data without us disclosing too much about who we are, who is the data about, and so we just want to share the results in this group. Let's talk a little bit about the homomorphic side of it. You have the homomorphic encryption organization that is standardizing homomorphic libraries and algorithms. They identify a handful of industries that are showing interesting use cases, like financial industry, healthcare, and other industries. This is a retail. They're using machine learning in this use case for secure multi-party computation. So they are protecting the data. They want to share it with retailers, banks, and advertising companies. So from retail, we go into fintech. So this, they have this confidential information. They need to be compliant to California CCPA and GDPR. And they want to use analytics in a privacy respectful way. So they are respecting data residency. So they are using these techniques that we're talking about before here. Another fintech, a bank that is sharing in their group. They do analytics and they want to put some data protection in place. So they decided to use differential privacy and k-anonymity, and it provided the usefulness, and it's also compliance to GDPR. Going back to secure multi-party computation, the old model in the middle, you centralize and get the data into a central point. The new model on the right-hand side is, as we mentioned before, you protect the data and you can share it on a peer-to-peer basis. You are using homomorphic encryption or other techniques to selectively protect the data, sensitive data in a fine-grained way. A little bit more about homomorphic. And at the top, homomorphic encryption is just asymmetric algorithm that's encrypting your data. And it's a new group of algorithms that can allow you to do certain operations, not all operations, that's not realistic. And this is from health. They have DNA samples, very sensitive, and they want to share it in a secure way. So they're using homomorphic encryption to protect that data. And it's very simple. You encrypt data feed, you send it over to the right, some operation is performed, could be multiplication or addition of field, and the encrypted result is sent back to the client. Trusted execution environment. I think I mentioned enough about it already, but it's just to summarize, it runs on a secure chip that it runs in the cloud. It's not as scalable as software, but it's kind of a middle ground. You can get some good scalability by using it. It's not a certified, validated FIPS 140 HSM hardware security module. So it's maybe not used for key management, but you can hide, you can protect some operations on sensitive data, you can protect code that is running in a secure environment. Differential privacy and k-anonymity. K-anonymity is very related, but differential privacy is kind of the emerging. It's already used by Google and Apple and the big collectors of PII or sensitive data. So they are using it to dummy down the data, aggregate the data. When they get enough transactions, they delete the details and use the aggregated data. There are 6 different models. Some are good for analytics and machine learning. Some are well studied, and some are adding too much noise and have other issues. So you can see the red and the yellow maybe not good for many use cases. So pick your model depending on your use case. K-anonymity, it's like hiding in the crowd. You filter out individual identifiers. So you can see an example on the left-hand side that where we applied k-anonymity, and on the right-hand side, you can see what the data looks like. So you can set different levels. You have different parameters where you can specify how granular do I want this data to be, or how many should be in the group that I disclose. How big should the group be to not single out individuals. At the bottom right, you can see that both these models are applying a filtering, and they are kind of in the background filtering out your data sets. So they are operating on your stored data. Zero Trust, it came from PCI DSS, where you had a network segment, or you had a desire to segregate your cardholder data environment, your CDE. So you can put that, for example, in a network segment, and then you don't need to care about what's outside, as long as it's not reaching that cardholder data inside your segment. So Zero Trust is saying it's not good enough to just check you when you enter the environment, or when you log in, or when you come into the network. Zero Trust means that we will continuously challenge who you are, where you're connected from, what asset are you actually touching right now. So it's a dynamic model, and you can see typically it's done via gateway in front of the data resource. You have the policy administration at the top, and it's a little bit like attribute-based access control, ABAC, which is different from RBAC, role-based access control. Role-based access control is typically static. you have a role, you put the user in a role that can access certain data elements, data. With attribute-based, you are on top of that saying that, hey, let's look at the context. Where is the user connecting from right now? And other contextual attributes or facts regarding this particular request. You are challenged on a dynamic way that goes beyond your static role-based access control. Let's go back for a second and kind of put zero trust architecture in the picture that we talked about before. On the right-hand side, you can see zero trust. It's, of course, connected to data security policy. We can see it on top of the CTA or ZTA. And the zero trust architecture is defined in a standard by NIST, US National Institute for Standards and Technology. And it consists of the database data security policy, which can apply dynamic data masking. You can see on the right-hand side that we talked about before. And we already talked about the other components here, but it's the data policy connection to how we protect data. How do we protect how are we using different data protection techniques for different data? Should we be concerned about privacy or compliance with security? Well, it's about the balance. So for each, I mean, there are standards and regulations and frameworks and things, technologies, but for each organization, you have your own use cases. You have a certain industry that you're playing in. You have certain type of data, and depending on what is your risk appetite, we always need to start with risk management. We need to understand why are we doing this, and then talk about, okay, what should we be doing? And then further down, we need to pick technology. How do we do this? And so, but start with the risk management. And the risk management will deal with we talk about risk appetite. How do I want to address different risks? And there are 4 ways to address the risk. You can accept it, and you can do these other things. You can have complementary, or you can complement that with an insurance. But insurance are starting to get a little bit cold feet. It's harder and more expensive, and they are kind of pulling out from different situations. For example, where you have risk management coverage and so. And insurance is, yeah, you have it for your car, but your car needs to be safe. It's not just enough with insurance. You have it for your house and so. So it's all about the balance that is, start with the risk management, and it's getting all these pieces together, depending on the regulations you are under, the threats that you see for your industry, and the time, point in time you are in right now. You define your rules and policies to the left. You decide on certain controls for different things that we talked about before. So it's all starting with risk management before you pick any technique, tool, vendor, and approach. Private setting section. I just want to mention it because it's it plays into secure communication between partners. You want to see if you have common partners between different organizations here. and you exchange information that is keeping the data private. So PSI plays into this multi-party computing. We talked about the range of different techniques. So I picked a couple of them on the left-hand side. And some of them are good for data warehouses. We talked about that. Some are good for distributed environments, not all of them. And some are particularly used in on-prem, public, or private clouds. It's kind of a navigation chart. And it comes down to understand your options. They may look similar, but they are different like night and day. So by understanding your data protection options, you have a much easier way to pick how you should protect different data. We talked about quantum, and if you can use random numbers to replace sensitive data, like many PII data, you use tokens instead. You don't need to care about the issues with quantum computers for that type of protection you're applying for that type of data. And machine learning is coming faster to a place near you, faster than we think in many cases. Just to summarize, what we looked at on the right-hand side is pretty simple things. You have, for example, the source data with age, region, and so, and you apply some type of generalization to just dummy the data down. You can see the example. You add, as we said, you add some type of noise to your data. Let's just mention synthetic data, what we mean by that. It can be either totally artificially generated, as you see on the top, on the right-hand side. The text is wrong at the bottom, because here it should say that some of the data is generated from your original business data. So it's a mix. You have a combination at the bottom. So again, you put your data down in the data store, you have it protected, and that data can go anywhere. It's protected under your control, outside your control. You can share it if it's properly protected. So you are in a much better place than before. Let's summarize what we talked about with techniques. We talked about risk reduction. At the end of the day, it's a lot about reducing my risk. So these different techniques on the left-hand side, they can help me or not help me with different types of risk limitation or lowering the risk. So at the far right, you can see what are these different techniques good for from reducing my risk. So when you go down into the weeds, you can specify it like the risk of inference, risk of linking, risk of singling out. We don't need to go down further here. In the middle, you can see where do I typically use this? Is it for data in transit, in use, or storage? And to the right, you can see what kind of data is it applicable to identifiers or to all attributes. You can see kind of the landscape here. We talk about risk a lot, and you want to share data because users can do their job if they get data. You can lower the risk by sharing sensibly, granular, like tokens that or dynamic mask data, you can lower the risk and still share a lot of data, so users can be productive and innovative. Or we go into the cloud, it will not look the same. You think you have your policies on the left-hand side on-prem under control, but in the cloud, things are called different things. And the security controls, you know, the Active Directory, the accounts, the projects across Microsoft and Amazon, they are not the same. You assign authorization in different ways. They mean different things. So it's that we cannot just move to cloud and assume. We need to understand what is the difference between an identity, an account, and a project, because they are dealt differently. So it's a challenge, and we need to learn the cloud language. And the cloud vendors, they need to speed up what they can do. They are starting to get more mature. But don't expect that they have the web application firewalls as you know it from on-prem. Don't expect that they have the key management and other techniques that you know from the on-prem environment with third-party vendors. So it's a learning situation. We are getting better. And finally, don't assume that they have the policies, default policies that you like. They want to sell compute to you. So typically they are very relaxed in their policies. They typically allow everyone to do anything and use more compute and charge you more. So the good news is that these policies, the default settings, are getting a little bit tighter. But you need to really check what are the configurations that you are using in the cloud. Otherwise, you will have a disaster, and the default configuration is not protecting your data. And if you look at the contract, they are not responsible for your data. It's you. You collected that data, and wherever it goes, you are responsible. You can outsource the operation, but you are on the hook. FINRA, it started to get interesting slowly. Gartner is saying that it will take some time before it's really hype, a buzzword. But we should mention that when you do your risk management, FINRA should be part of that picture or becoming a part. So Gartner is showing a risk pyramid, and they are putting FINRA to analyze the financial impact. You have your data privacy risk at the bottom, and you will translate that up to something that makes sense for the board, for the executives. Otherwise, you will not get the budget you deserve, and that is the right thing from a risk perspective. And this is Gartner scorecard where it's good to measure things. You have the financial on the left, the operational at the bottom, and I don't want to get into the weeds here, but look at that information. It's good to dive into it, because you need to tie it to risk and financial goals. This is just for reference. I talked about the top one, which is an international privacy standard for data protection techniques. Further down, you have different privacy standards. These are the 11 published by ISO IEC. They cover cloud, frameworks, and more. A couple of other references that I recommend. We talked about homomorphic and post-quantum and more here. So thank you very much. It's been exciting to talk about my favorite topic with you.
Oh, thank you so much. It is so obvious. This is one of your favorite topics. That was absolutely fascinating. I noticed you had almost 80 slides.
Yeah.
And you lost me, certainly, after around about slide 20. I have one or two brief questions for you, but we will aim to finish in about 5 minutes' time. Anyone else? Do you have any questions, or should I ask Ulf my question? David, do you have any questions?
No, you do your first question first.
Okay, fine. Ulf, I noticed that early on you covered a very topical subject. Do I need to address ransomware and other attacks on data? Well, of course we do, but I felt when you said that we can protect our data, we can monitor access, we can do offline backups, and we can test restore procedures, that doesn't go far enough today, does it really? Because we need to try to protect all the entry points as well. Can you give us any further tips about how we can protect our essential data today against increasingly sophisticated ransomware and criminals who use ransomware as a service?
Yeah. It's becoming more and more of my favorite topic also. Some ransomware want to destroy your IT system, so you can no longer run. But put that aside, because it's not a dominating issue in ransomware. So let's move to what they try to do in most cases. They try to encrypt your data so you can either recover the data by dealing with the criminals, or if you have a good backup, you can restore and get going again. But over time, they saw that they can get money from extortion. They can steal your data and ask for money, and if you don't pay them, they will disclose the data, which can be disastrous for many organizations. So it's becoming a bigger and bigger issue that they actually stole your data. And the answer is that if the data is protected, they have nothing. How did they come in? You talked about entry points, and they're coming from everywhere. They keep changing. It's a cat and mouse. They keep changing the attack vectors. They come in from all angles. We talked about phishing. Yeah, phishing sometimes is a concern, but when we are getting better, they change their tactics. So the only thing we can be sure about is that the next wave of attacks will come in from different ways. So it's let's talk about. I was surprised about SolarWinds.
Yeah. I'm really sorry. Really sorry. We're almost out of time. If you could just tell us briefly. Yeah. Thanks.
No. Yeah. So my thinking is that it's not good enough to protect the entry points because they are already inside. And they will come in from another direction than what I expected and what I protected. So I think the strategic move is to protect what they are trying to steal from you. That's kind of my bottom line.
Well, it sounds eminently sensible, but I think this debate will continue for some time. But something else, David said during the chat that he's going to have a look through your slides again because they're so complex and involved and interesting. And I think that applies to most of us. You have given us some very valuable information there. And I think one of the things we need to do, as well as protecting our data, is to take a good look through this very useful video we've taken of your webinar, Ulf, and try and improve our individual techniques using this. Let me just say thank you very much on behalf of our audience for this very good, excellent webinar, Ulf. Again, thank you, I should say. Yeah, and to everyone in the audience, thank you very much for sticking with it. Maybe you're far better than I am at absorbing all this information. I'm still on around about slide 20, as I say, but I hope you got some valuable insights and some valuable reference points from these slides. And as David has already said, this is being recorded and the video will be available, and I believe you will be sent a link to the video to make further use of this valuable information and to look forward to seeing our great presenter, Ulf Matsson, again. So thank you very much and look forward to seeing you next time. Bye for now.
Thank you.
Thank you. Stay safe.